All right, welcome back. We're going to score lessons 73 and 74 right now. So open your books to lesson 73, your homework to lesson 73, and your books as well maybe. If that helps. Lesson 73, number 1, a kite is flying at a 45-degree angle of elevation above the ground. Find the length of the string if x is 20. There's two ways you could do this. One is simply just remembering the 45, 45, 90 triangle. And the other is actually the sine, cosine, tangent. So since the kite is flying at 45 degrees, let's go this way since that's the way the book is, x plus 20, x plus 20. Well, we know that they are, looking for my eraser, here it is. This is 45 degrees, then we know that these two are equal. We also know if you have a 45, 45, 90 triangle, this is 1, this is 1, this is the square root of 2. So the first step, it says if x equals 20. If x equals 20, and of course you're screaming that's x plus 2, not x plus 20. If x equals 20, then this length becomes 22. So let's go ahead and write that in. Of course, this one is 22 as well. X plus 2 is 22. Without sine, cosine, tangent, you can just look at this and say that this length right here, the length of the string, kite's up here, tail, whatever, and here's the string. So the length of this string is the square root times bigger than this. So it's 22 times the square root of 2 up here. 22 times square root of 2. Does that make sense? I think you can see that. Which, if you use your calculators just right there and say 22 times the square root of 2 equals, the string equals 31.1126, or whatever, 31 feet, approximately. It doesn't really give an indication, so it could be yards or whatever, but 31.11, 31, whatever, somewhere in that range is the correct answer. You can also get there by sine, cosine, and tangent, which is maybe what some of you did, and that's fine. Either way is perfectly fine. If you go sine, cosine, and tangent, then you know what these two are, but you're really concerned what is this length. And so you can pick either this one or this one to get you here, either one. It'll just determine which one you do. Remember, put your thing up here if you need to. Oscar has a hold on Arthur. This is the sine, this is the cosine, and this is the tangent. Those are your ratios. So in this case, we decide we're right here. This is our angle, so that's where we're going to be at. 45-degree angle right here. And we say, I'm concerned about this, and let's just pick opposite. So opposite and hypotenuse. This is for Susanna maybe. Knowing which ones are which. So this is a right triangle, and all right triangles will have three parts about them. There will be an O, an A, and an H. The H is always the hypotenuse. So the H is always this one, and then the O, the opposite, and the A, adjacent, all depend on which angle you're at. Are you here or are you here? And if you're on this one, then these are one thing. If you're at this one, then they swap. So it's always based on which angle you're at. In this case, we're here, and let's erase this so that doesn't confuse us. Let's just decide we're going to use this one. If we only knew this was 22 and we knew this is x, then we say what I'm dealing with is I need to know the hypotenuse. So I need to find one of these with an h in it, and then the other one, since I'm here, then this side is the side opposite of this angle. This side is opposite of this angle, so that is an opposite. So I need to find the H and the O, which is this first one. Then I can say, so for this triangle right here, the sine of 45 degrees is equal to opposite over hypotenuse. Opposite is 22, opposite over hypotenuse. Once you get there, you need to just solve for H. Excuse me. Get H by itself, and this is one way to do it. Here's your equation. To get H by itself, the first step is, since this is divided by H, then let's take both sides times h, which puts h over here. H times the sine of a 45 degrees is equal to 22. Well, that doesn't help you say, but it does. It's just two steps. Now, since it's h times the sine of 22, you can divide both sides by the sine of 22, and that'll say h equals 22 divided by the sine of 45. I think I was saying sine of 22. Anyway, sine of 45. When you look back what you did, you actually just swap these two, and maybe there's a quicker, better way. You can tell me that if there is. But once you get this properly set up, based on this, then you just need to rearrange and work it until you can get h by itself. And so the way I did it again was, since it's 22 divided by h, I'm going to take both sides, multiply both sides by h to get rid of it here. That puts h over here, so it's h times the sine of 45 equals 22. Now, since it's h times this, then I can divide both sides by the sine of 45, and that cancels this out because it's h times the sine of 45 divided by the sine of 45, which does away with that and leaves the divided by sine of 45 over here. So then you can put that in your calculator. 22 divided by the sine of 45. That should get you that 31.11 answer that we got with the 1 and square root of 2 thing right here. It's just you can use this one since it's a 45 degree, or you can use this sine, cosine, tangent. Going back to this thing right here, just to make sure we're there. So again, any right triangle, if this angle is 20 degrees, then that is where you're stationed. That is your perspective. And again, the hypotenuse is always the longest side, and it's always the side opposite the right angle. And then one of these sides is going to be opposite, and one of them is going to be adjacent. In this case, if the 20 degrees is here, then this side is adjacent. This side is next to this 20 degrees. So for this problem, this side is A, and this side is O. If I somehow had to switch and go up to this one and say this is 70 degrees up here, and I don't know what this one is, now my A and O switch, because now this side is adjacent. So this side would be the A, and this side over here would be the O. This side always remains the H, hypotenuse. Hope that helps. Again, A and O are strictly based on where are you located. Whichever angle you have degrees about, whichever angle you're looking at, you're stationed there, that's your perspective, then that'll be the adjacent, the one that's next to it, and the one that's opposite will be the O. And then you can decide sine, cosine, and tangent. Once you get that formula set up, then you have to solve for the unknown. All right, let's keep going. Hopefully that helps. Number 3 on 73. Draw 3 circles that share 2 common tangents. 2 common tangents, the most easiest way would be like this in a line. 3 circles. You can have them touching, it doesn't matter. 3 circles sharing 2 common tangents, that would be an easy way to do that. Number 7. Assume that the segments that appear to be tangent are tangent, and then find the value of x. So this is 7, problem number 7 on 73. And assume the segments that appear to be tangent are tangent. Again, just looking at that drawing, 2x positive 5 is equal to 4x negative 9. That should be your equation. 2x plus 5 is equal to, those two sides are congruent. You have circles and you've got like this, but you're just dealing with this side right here, and so it's the same as having a circle with points drawn, and you know these two are congruent. So that amount equals that amount. So for x equals 7. For number 7, x equals 7. All right, number 11, we discussed this one, I think, somewhat, and I don't know if we arrived at the correct answer or not. Maybe a little confusing, but it says, a building's shadow is 137 meters long. The sun is at an angle of elevation of 60 degrees above the horizon. So here's the building. This is how I would do it. Here's the ground, and here is the sun angle. The sun is up here somewhere shining brightly, like you always draw suns. And that angle, if I do it right here, it goes like this and goes right to the sun. This angle here is 60 degrees. So it should be steeper than that. I don't like that angle, so let's move the sun up a little bit and say that the angle of the sun, it also happens to be that. But here's the sun shining. This angle is 60 degrees. And then the shadow right here is 136, whatever it is, 136 meters. So it is the amount on the ground. The shadow shadow would be on the ground. That's the place that you can see shadows the best, is on the ground. And then it's asking how tall is this. So this is your unknown. And since this is 60, your 60 is on this side right here, then you're dealing with this side, which is what? If you're stationed here, this side is A, and this side X is opposite. So opposite is this side. So you want to find one of these functions that deals with opposite with an O and an A. OA, which is that is tangent. Seems like the bell is ringing more these days than any other days, but that's not true. Opposite and adjacent. The tangent of a 60-degree angle is equal to opposite over adjacent. Opposite is x, so it's equal to x over adjacent, which is 136. That should be how you work on it. And now we just had the power go off. And the power come back on and blink and the bell rang and it's still sputtering, but the mighty iPad continues to record. All right. Tangent of 60 degree is equal to x over 360. And then rearrange that. Since this side x over here was divided by 136, I said 360, I don't know where that came from. X divided by 136, then take both sides times 136, and that gets rid of it on this side. So you have tangent of 60 degrees times 136 equals x, or x equals the tangent of 60 times 136. So in your calculator, you can do it however. I'm going to put 136 times 60-degree tangent equals, and x equals 235.59 rounded. Okay, that is not what we're looking for. We're looking for leaving your answer in radical form. And now you almost have to start over. I forgot about that. I saw that earlier. But let's just make sure we're right. 136 times 3 equals, you still get the same answer, but it says leave it in simplified radical form. And what that means is thinking about a 30, 60, 90 triangle, if I can draw it right ever. I don't want to do that way, I want to do this way. 1, 2, square root of 3. So looking at it this way, your 60 is down here, and this is 130. This is again the proportions of a 30, 60, 90 sides. All sides would be in this proportion. So if you have a triangle that's 136 down here, and you want to know what this is going to be the square root of 3 times bigger. So 136 times the square root of 3. And you could have gotten that from your calculator if you say 60 degrees and the tangent. My calculator says 1.732050808. If I take the square button, in other words, I just square this number, then it goes to 3. So the tangent of 60 is equal to the square root of 3. And that's because its tangent is opposite over adjacent, opposite over adjacent. Or opposite over adjacent is the square root of 3 over 1. That is the tangent of a 60 degree. I don't know if that makes sense or not. And I don't like the way they do it, so I'm okay if you would put this answer, even though it says leave it in simplified radical form, and you'd say, well, I didn't use simplified radical form, I used the sine, cosine, and tangent, and it never told me the simplified radical form, then I'm okay with that. That's an okay answer, 235.59. Hopefully it makes sense how the tangent of a 60, if you put in your calculator, the tangent of 60 is equal to the square root of 3. So it would be square root of 3 times 136. You can do it this way. You can also get it by thinking about a 30, 60, 90 and these proportions. But we'll let it at that. That's an okay answer. What they're actually looking for is 136 square root of 3. That's what the book says. But either one of those is good. They are exactly the same answer. And there's multiple ways to do it if you have a 30, 60, 90 triangle. The sine, cosine, and tangent, those apply to any right triangles. These are always right triangles. Whenever you're dealing with sine, cosine, tangent, it better be a right triangle. And so you can use sine, cosine, and tangent. You can use Pythagorean theorem if you know two of them. You can use 30, 60, 90. Most of the time with trigonometry, you're only given an angle and one side measure, which the Pythagorean theorem won't help you with that. And a 45, 45, 90 works, and a 30, 60, 90, we know, as long as we know one side, we can figure the rest on those two specific triangles. For sine, cosine, and tangent, they apply to any right triangle. The bell continues to ring. All right, we are at 11. That means we're ready for 17. Pilot in a plane sees a lake at an angle of depression of 31 degrees. The plane is cruising at 20,000 feet. How far away is the lake from the plane? Just to get a practice here of drawing out the problem so we know where we're at. Here's the ground, here's the pond, here's the plane. This is how I used to draw planes all the time. When I was little. This is how we draw them now. There's your plane, there's the windows. There's a horizontal line this way, and there's also a line like this. Does it say angle of depression? I think it does. He sees a lake at an angle of depression of 31 degrees. So this is 31 degrees. And he is 20,000 feet over the ground, 20,000 feet above the ground. The question is, what is this distance? How far away is he from the lake? Not the horizontal, but the hypotenuse distance. So this is x. Now, this might look confusing because my 20,000 is way over here. Well, remember, this and this are parallel lines. This line is parallel to this line. His reference line is horizontal, just like the ground is. So you can move this 20,000 wherever you want it. You could move it right here, and this be your triangle. You could move it over here, and this be your triangle. If this is your triangle, then be careful with this 31 degrees. This 31 degrees is up here, it's not down here. And this is a bad drawing, it doesn't look that way, and it would really be a lot flatter. So let's make it flatter. 31 degrees, so let's move the lake over to here, and his 31 degrees is a little steeper, so that looks better. 31 degrees, and this is 20,000 right here. Again, I put it there above his plane, but it can be over here, it could be all the way over here at this 20,000. This is where you need to be a little bit careful. If you're going to move the triangle to here and use your reference point here, you can find this angle, but you're just going to go 90 minus 31, which is 59. So then you would use this triangle in here and here. You'll come up to the same answer. The way I would say to do it, two ways you could do it, and one is to say, well, this is a transversal, and these two are alternate interior, so my 31 goes down here, and this is where I'll reference the problem from. Again, this x is what we're trying to find. The second way to do it is just to move from this bottom triangle, move up to this triangle, and say, here's my 31, here's my unknown, and here's my 20,000 way over here. This is my right angle. Any of these three ways will work, just as long as you continue to use this properly. I would just stay with the 31 degrees and either use this triangle up here by moving this 20,000 over here and say, this is my triangle, or remember alternate interior and move it down here and use this triangle. You can use this 59, you just might get more confused if you do. It's just another area to get confused. It will work fine. It's just then your reference point becomes what's, sine, cosine, and tangent of a 59 degrees is this over this or whatever. So I'm going to leave the 59 go. Just recognize you can't jump like this. You have to jump across alternate interior or stick with this triangle up here. At the beginning of these lessons, we said angle of depression and angle of elevation are equal. And so angle of elevation would be if somebody's down here, if the duck is on the pond or the lake, down here's the lake, and he's looking up at the plane, then his angle of elevation is going to be the same as this guy's angle of depression here, which is different than this thing. I hope I didn't thoroughly confuse you, but we're not even done with the problem yet. Let's go with this top triangle. I'm going to go with this triangle up here and use it this way. So here's my perspective, and I want to know this, and I know this. So these are my two that I'm working with, and I say, what is this? This is the hypotenuse, it's always the hypotenuse, the longest one is always the hypotenuse, it's opposite this right angle, so right here is this one, and we're dealing with this triangle up here, this upside down triangle. And even though it looks upside down, you can still work with it. So H is this, hypotenuse. And then what is my other unknown? It's this one way over here, and is it adjacent to this side, or is it opposite to this angle? This is the top angle I'm dealing with. It is opposite, so this is O, so I'm looking for an O and an H. And the O and H is here. So for this problem, the sine of a 31 degree is equal to 20,000 over an unknown. And I hope I did that right. Sine of 31 is 20,000 over x. So you can rearrange this for x, and it will become x equals 20,000 over the sine of 31. And how do I know that? Because I just do my two-step thing that we talked about earlier and say, well, since it's 20,000 divided by x, let's take both sides times x. So it's x times the sine of 31 degrees equals 20,000. And it feels like there'd be a better way to do this. But now, since it's x times the sine of 31, now let's divide both sides by the sine of 31 to get x by itself. So x equals 20,000 divided by the sine of 31, which I think is what I said earlier. So your calculator, go to your calculator and say 20,000 feet, 20,000 divided by the sine of 31 equals 38,832 feet, which is a long way around to say the correct answer for that problem is D. Correct answer for number 17 is D, 38,832 feet. I know we took a while on that one. I wanted to try to talk about the triangle thing and how that you can use multiple triangles and hopefully not confuse yourself. And also just practice with using opposite, hypotenuse, and adjacent. I'll say it one more time. Hypotenuse is always, the H is always this long side, and then your O and your A are determined by where you're at. What perspective are you at? From this angle, this side here is adjacent, and this side is opposite. So then you just, once you get them labeled properly, which is the hypotenuse, which is the opposite, which is the adjacent, then you look and see which two numbers am I working with, and then find your function that matches those two letters. In this case, it's O and H. Number 20. Translation vectors u1 are 3 and -2, and u2 are -1 and -3. We talked about this when they're applied successively to each of the points. So you take point A, which is -5 and -2 and 5. We can do it over here, but we're not going to. -2 and -5. I'm sorry. A is -2 and 5, and then apply a change of +3. In other words, add 3 to the x and take 2 off of the y. And then from that point, add a -x, or take 1 off of the x and take 3 off of the y. And you come up with A double prime, that is, A prime prime, double prime should be, and this is how you would list them in your book, A prime prime is 0 and 0. That's where you got after you went from after you went from -2 and 5 and added those two vectors. Excuse me, U1 and U2, that's simply a name. I don't know why they named it that. They could have named them X and Y or something else, J and G. B prime prime is 1 and -2. B double prime is that, and C double prime is what? 3 and 0. 3 and 0. So that should be your answer for 20. Don't count it wrong if you didn't do these double prime things, but in theory it should make sense to you when you have a figure that was A, B, and C. Those are the vertices listed. The first transformation is going to be A prime, one of those, and then you did a second transformation, so you ended up A prime prime or A double prime. I don't even know how you're supposed to say that, but so don't count that wrong, but these should be right. 0 and 0 for A, 1 and -2 for B, and 3 and 0 for C once you do both of those translations. 23. Surveyor measures a 65-degree angle of elevation on the top to the top of an 800-foot building. How far is the surveyor from the base of the building to the nearest foot? 373 feet is the correct answer. And I guess for for practice sake, we will quickly go through it. 800-foot building, and he's 65 feet away. There's the building, 800 feet, and he's, is he 65? What does it say? He measures 65-degree angle. So he's looking like this. This is 65 degrees to this. And the question it asks is, how far away is he from the base of the building to the nearest foot? So you're concerned about this distance right here. You want to know this distance. So I'll erase this building just so it's simplified. So here's a triangle. We know this is 800 feet. And we don't know what this is, but we want to find out. This is label X, unknown. And this is 65 feet. So if we're positioned at this angle, then what are we dealing with? Which two letters are we dealing with? Well, this is the H. This is the hypotenuse right here. And we don't care about him in this case. So we're going to look for the function that does not have an H in it, which is this one. And then we need to decide which of these are opposite this angle and which of these are adjacent this angle. Well, in this case, for this problem, the X is adjacent and the 800 is opposite. So the tangent of a 65-degree angle is equal to O over H. Oscar had A hold on Arthur. O, H, opposite, adjacent. So opposite is 800 over X. The tangent of a 65-degree angle is equal to 800 divided by X. If you solve that, again, if you do this often enough, you'll just remember and know that if X is on the bottom, you can just swap these two. And there's a better explanation for that. If you don't remember that, then just say, well, since 800 is divided by X, let's take both sides of the equation times X. Let's multiply both sides of the equation by X and see what happens. That means X times the tangent of 65 degrees equals 800. And then, since we're trying to get X by itself, then we're going to take both sides divided by the tangent of 65. So X is equal to 800 divided by the tangent of 65 degrees. Get your trusty calculator and ask it what 800 divided by the tangent of 65 is, and it will tell you that it is 373.046125. And does it ask for rounding? Not really. So this is okay. It doesn't say to round, but it doesn't say not to round. So 373 feet is correct for problem 23. 29. Problem 29. Assume the segments that appear to be tangent are tangent. Find CD, CE, and BC. Again, it's this fact that tangent lines drawn to a circle from a common point outside of the tangent are congruent. So if you do the math, you find, well, first of all, you're going to see that 5 is listed for the length of AC, and you know that DC is congruent to AC because they're listed there, so X equals 5. If X equals 5, that'll tell you the 1, and then you can plug that in the other one, and 4 times 5 minus 12 is 8, and 3 times 5, 15 minus 7 is 8 as well. So CD equals 5, and CE and BC both equal 8. That's the correct answer for 29. All right, we are 28 minutes in, and we only have one lesson scored, but hang with us. We're going to finish the next one quickly, hopefully, and be done with scoring. Lesson 74, number 2. Lesson 74, number 2, we talked about this. Write a transformation mapping for a reflection T across the line y equals negative x. And we did it last night, so I'm not going to continue, but this y equals negative x, and you can do the thing, and you see that it swaps around. But without even doing that, you know that y equals negative x. That's the line, and that applies to the transformation mapping y equals negative x. So you're supposed to write in transformation mapping, or mapping notation, I always say that. So the translation of, or the transformation of points x and y become something and something. Well, the y becomes negative x. So what was down, the y position is negative x, and if you rearrange this, just solve this equation for x, negative x equals y, well, I want to know what x equals, so take both sides of this equation, multiply them by -1. Well, negative number times a negative number is positive, and so x equals -y, so you put -y right here, comma. The transformation of point x and y becomes -y, -x. And we saw how that was here, putting points in and how they swap back and forth. What was in the x position goes in the y position, and it changes the sign, and that's what the negative thing is about. So this is the answer right here for 2. 11. Computer-generated triangular prism is made by constructing a triangle with vertices as listed. I'll just draw it up real quick here. The vertices as listed were 0 and 0. I hope you can see this. 0 and 0, 2 and 5, 1, 2, 3, 4, 5 right here, and 4 and 0 right here. So here's a triangle, and now for each of these points, we change it according to the formula, which is 4 and 6, correct? Come on, I lost my place. 11. Yes, the transformation mapping is x plus 4 and y plus 6. So you're going to add 4 to the x and 6 to the y, and you get new points. This 0 and 0 becomes 4 and 6 because you're adding 4 and 6. So 4, 1, 2, 3, 4, 5, 6. Here's the new one here. This one was x of 2, and now you're going to add 4 to it, so it's an x of 6, correct? So 6 and 11, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up here, and the other one will be here, I think. 1, 2, 3, 4, 1, 2, 3, 4. So then it's asking you to graph all this, and it says translate it and connect the vertices of the pre-image to the corresponding vertices of the image, and we really should or could label all them and say prime, d prime, but you have two triangles, one that was here, one that was translated, 4 and 6, and then these lines connected, and there's your triangular prism. That's what you should have. I think you can see that. I hope you can. Number 12. An equilateral triangle is reflected across a line containing one of its sides. What figure is formed by the image and the pre-image? In other words, both of them combined. And if you have an equilateral triangle and you transform it across this, you'll get something like this. What is that shape? What is this shape right here? Let's erase this line so it's not confusing. It's a parallelogram because 30, 60, 90, or 60, 60, 60. It's a parallelogram. It's also a rhombus. Rhombus are congruent sides. So you could call it a parallelogram. You could call it a rhombus. I will take either one of those as correct answers for number 12. Number 13. Which trigonometric ratio can a hiker use to determine the horizontal distance to the lake, and it's labeled as x in the drawing? So again, this is the same idea of the airplane and the lake. You have to decide which triangle you're going to use in the drawing here. If you move that 20 meters over to where it goes up above the lake, I should draw it out here, but I'm just looking at my drawing in the book, and there's a mountain here and there's a lake here, and it says 200 over here, and the guy's standing here. And this is what you're trying to know, this horizontal distance, I think. So you could take this, and then, so this is not a bad looking hiker. Here's the lake. This 200 meters, is it? 200 meters can be here. But what they do is they extend this out and say 37 is over here, which is not really in a triangle. This 37 is not really in a triangle. Well, it's not in the triangle, but it is. Remember, alternate interior lines, you could take this 37 and apply down here and say this is 37. Now you have a triangle. Here's 37 degrees, here's an unknown, and here's a side. So in this case, you want to know this distance and the two that you're looking with. If you decide your station down here is opposite to this side, is opposite to 37, and this side is adjacent because here's the hypotenuse. This is your right angle. It doesn't look like it, but that's the distance right there, is this 200 meters. So opposite and adjacent would be tangent, so you use a tangent function. That's what it's asking, right? The tangent, which trigonometric ratio? So you use the tangent, and the whole thing would be tangent of 37 degrees is equal to opposite over hypotenuse 200 over A. Now it just says what is a trigonometric ratio, so you should just be able to say tangent. But it actually, in the book, it actually lists this thing right here. But if you just said tangent, that's fine. Some of you may have taken this 200 meters and brought it over here. And if you did, that's fine. You don't have the x then, but the x would still be, if the 200 meters is right here, the x would still be this distance. This, you know, the horizontal distance, I don't care if you measure it from the guy here on the ground or if you measure from the guy over to a point over top, it's still the same. So your x could move up here, and your 37 would be up here, and this 200 would be here, which you're still going to have the same thing. Since now you're up here, you're still dealing with an opposite side and an adjacent side. I don't want to confuse you by adding multiple things, but there's multiple ways to do it, and again, it's always just practice on which is the opposite side and which is the adjacent side. And if you're down here, this x is adjacent, and this 20 is, or 200 is opposite. If you're right here, the x is adjacent because it moved up there, and it's opposite. So you're still going to deal with the tangent function, no matter how you work that problem. Tangent is what you need. 14. Triangle DEF has vertices as given. Graph the reflection of triangle DEF across the line x equals -5. Let's go to the graph for that. Hopefully by now we're starting to make sense when we say graph the line x equals 2.5. This line is not really in the form of y equals mx plus b, and so we can't look at that and say, oh, what's the slope and what's the y-intercept? Well, there is no y-intercept, and if you solve all that, you don't really have to go with it, y equals mx plus b. You just look at that and say x equals 2.5. I don't care what else you do, I don't care what you do with y, x equals 2.5. So come over to the graph, put a dot at 2.5, here's 1, 2, and here it is, x equals 2.5. And if y is 0, x is 2.5. If y is 1 million, there, x is 2.5. So it's going to be a vertical line right here. I should have a straight edge. But it's going to be right in the middle at x equals 2.5. Every point along this line, the distance, the value of x is 2.5. 2.5 units over, 2.5 units over. X equals 2.5. That's the line. I know I'm beating a dead horse, but hopefully that makes sense. So that's the line you're going to reflect across, and lost track of where I'm at again. 14. So then you draw in the line that was given, and D is at 3 and 4. D 1, 2, 3, 4. Here's D, and F is at 6 and 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6 is here, and E is 7 and 2. 1, 2, 3, 4, 5, 6, 7, and 1, 2. Remember, when you're counting, X is always first. Y is always second. Here's your triangle. Excuse me. And it doesn't quite look like the one in the drawing, but that's okay. Did I mess something up? Hope not. This is supposed to be 6 and 6. This is supposed to be 7 and 2. 1, 2, 3, 4, 5, 6, 7. And this is supposed to be 3 and 4. Now reflect it across the line, and we'll do this one first. For this line, x equals 2.5, first thing you can do is, since you're reflecting across a horizontal line, you know that the y values will not change. Up and down does not change a bit because you're going straight across. You're just flipping it across. And so all you're concerned about is the distance from the dot that you're doing to the line. This line went right here at 2.5. Since this is at 3, this is a half a unit, so we're going to change it to a half a unit. The new D point is right here, which is 2 and 4. So the y value stayed with 4, and the D changed to 2 because it was half a unit away from the line here. This line is 1, 2, 3 and a half units. So there's your half, and then 1, 2, 3. So your new point over here is -1 and 6. X changed however much away from the line it is, and your y value did not change. This one is, we know it's going to be over here somewhere, and the y value we know is going to be 2. We know that already. Just what is the x? It was 7 here, but it is how far away from the line. Since we're not reflecting it on the line 0, then we're going to say how far away from the line, and it'll be that same distance away. You could consider it like this triangle is a connecting, and then it just hinges across, and where does it land? 1, 2, 3, 4, 4.5 units away from the line. Here's your half, 1, 2, 3, 4. So it's right here, which is a total of 1, 2, negative 2 and 2. So F prime is negative 1 and 6. I don't know if you can read my writing. F prime is negative 1 and 6. D prime, where is he? Up here. D prime is 2 and 4. D prime is 2 and 4. And E prime is negative 2 and 2. And then you would draw that triangle, and it would look the same. It would look the same, just flipped over. All right, 40 minutes in and still going. This is a record. Number 19. Reflect PQRS across the line y equals x. And that is the drawing that's given. So PQRS reflected across line y equals x. And I'll just draw it quickly here. A line y equals x is y equals x. Now this one you can put into the slope-intercept form and read it and say y equals mx plus b. That's your form. So what is the y-intercept, which is b? What b value is over here? What's here? 0. There's nothing. So that means it crosses the y line at point 0. And then the second thing is, what is the slope? What's the value next to x? 0 or 1. I mean, there's nothing there, so it's 1. Because if it was 0, some number times 0 would be 0. It needs to be 1. So your slope is 1. 1 over 1. Your rises up and runs. So that gives you the line. It's actually drawn in there, but your line is a 45-degree angle going that way at every x equals y, whatever y. If y is 1, then x is 1. If y is 10, then x is 10. It's just up and over the same amount. And then draw your line, draw your square in there, and your square just touches the corner, and you're supposed to reflect it across this line. Well, obviously, any points that are on this side of the line will be on this side, and any points that started out below the line will be above the line. So this line, this point comes up here, and your square goes down here. And your points, I'll just read them quickly. Your points should be the new Q, which is Q prime, is 7 and 1. R prime is 7 and 5. S prime is 3 and 5. And P prime is 3 and 1. And you should have those labeled, and it should look similar to that with the drawing flipped over. Now my image, my triangle there got a little bit bigger, but I mean my square got a little bigger. All right, 1927. The building is 40 feet tall. If a person stands 40 feet from the bottom of the building and sees the top, what is the angle of elevation from the person to the top of the building? Now, we'll get actually to some of this where we deal with finding angles, but you should be able to recognize what angle it's going to be without using the inverse sine functions, which is later on in life. Maybe we'll not get to it. But if a building is, wow, that's a complete non-functional marker. Building is 40 feet, or meters, I don't remember. I think it said 40 feet. 40 feet tall, and that's over here. And the guy is standing 40 feet away, 40 and 40, and it's asking what is this angle. If you go over 40 and up 40, this is going to be a 45-degree angle. Hope that makes sense. We just talked about that over here. This y equals x, it's the same thing. Going over the same amount, going over 5 for the x and going up 5 and you get on that line. That line's a 45-degree angle. And we know that because 45-degree angle has 1 and 1. And the square root of 2, 45 degrees. So if this is 1 and 1, then that's 45. Or if it's 40 and 40, it's 45. 45-degree angle. All right, last one, 28. Parasail is attached by a 40-foot rope to a boat that is towing it at the angle of elevation from the boat to parasail is 34. About how far above the water is the parasail? Now, I don't know how many of you have been parasailing, but if you ever get the chance, you should take it. It's kind of fun. I have been, and this is an exact problem that I talked to the guy about because we'll get to the problem in a minute, but my guy had a boat, and a big boat, and he had a long rope, and I forget what I paid for. You pay for the, if you want to go 500-foot rope or whatever. This person is a 40-foot rope, which is kind of small. I convinced him to go 1,000-foot rope, 1,000-foot rope, and it was a pretty good breeze, and I don't know this angle. I didn't have a measurement here, which my angle of elevation would have been like this. I was up here, this big old curtain, a couple strings, and here I am dangling by this rope. I guess I'm there dangling somewhere. And I'm looking straight out, and I can see down the Florida Keys, and I can see a long distance. I can see on both sides. I can see water. I can see, I don't know, miles and miles, and felt like hundreds of miles. And when I looked down, it really felt like the boat was about like that. Like he was almost below me. I felt like, so the bigger this angle, the higher up I was. If this is 1,000 feet, I don't know how I was. It felt like I'd been, whatever. But it was great fun. Back to the problem. This person, his 40-foot rope, and the angle of elevation is 34 degrees. So not real aggressive. 34 degrees. And this is 40 foot. I would say I was way above 45 degree at, way more than a 45 degree angle. 40-foot rope and 34-foot. Here's the boat. I'm not doing a good drawing. And here's the parasail. Question is, about how far above the water is the parasailer? And the answer is 22 feet. So if you got 22 feet, you can pause this video and go home. Where are we at? Yeah. If you didn't get 22 feet, or if you're still not sure about it, then stay tuned. The question is, how far above the water? X is right here. Here is your station. This is where you're at. And what are you dealing with? You're dealing with the hypotenuse. Here's the hypotenuse because this is the right angle. Hypotenuse is always the longest. You're dealing with the hypotenuse, and since you're stationed here, even though you're being towed up here right now, this problem, you're looking at this. You want to know what is the angle. You're dealing with this one. What is this? Is this O or H? This is O. It's opposite. So you're looking for an O and an H, which happens to be the sine. So you say the sine of a 34 degree angle is equal to some number over 40. Since you want to solve this problem for x, and it's x divided by 40, take both sides of this equation times 40. So 40 times the sine of 34 degrees. I don't care if you do it that way or if you say the sine of 34 degrees is times 40. It doesn't matter. All that equals x. So x equals 40 times the sine of 34 degrees. If you use your calculator correctly, 40 times the sine of 34 equals, and you get 22 something feet. And it said, did it say about how high? Yeah, about how far above the water? 22 feet. So back to the guy here, 22 feet above the water. That's great, that's good, that's not real high. Actually, if you're going to go parasailing, aim for something above 22 feet above the water. All right, I hope that helped. This is the longest homework scoring lesson video we have ever watched or endured or whatever. It's 48 minutes long. That's okay. We got the scoring done, and hopefully those make sense. If you still have questions about some of those, you can forward them to the correct spot, which would be me, I guess. Thanks.